Hey, welcome back. This is section 2.2 on polynomial functions, part 1. Today we're going to talk about how to identify a polynomial function and also the lead coefficient test to look at the end behavior of polynomial functions. Alright, so first of all, properties of polynomial functions. A polynomial is any function in the form of f of x equals, and this is like the strict notation, but basically you've got some term right here with some coefficient variable, and you've got some power. Okay, we've seen that before. And then we go down in power, so this is the second biggest power, and then so on all the way down to some constant over here at the end. Okay. So many examples, but one would be like x to the fifth minus 3x to the fourth plus 2x plus 1 would be an example of a polynomial. Alright, so a polynomial function will always be continuous. We talked about that continuous thing where the pencil never leaves the paper. Okay, so there's no asymptotes and no breaks. The graph will be smooth and have rounded turns, no V's. Everything will be nice, smooth transitions from one to the other. It will have at most n real solutions, which we'll talk about later, and n minus 1 terms, which we've talked about before. So if the fifth power function, like this example here, it's going to have up to 5 real solutions and up to 4 terms, so up to 4 maximum and minimum values. Okay. Alright, so the graph of a polynomial, we should be familiar with these. The basic idea is that if you have a parent function, okay, parent function where it looks something like that, x to the n power, if that n is even, so if it's x to the second, the fourth, the sixth, the eighth, anything like that, you're going to have a graph that looks like this, pretty much like a parabola. It's going to change a little bit. You could have some turns somewhere down in here, okay, but it's going to be that same basic parabolic shape. And then if n is odd, meaning x cubed like we have here, x to the fifth, x to the seventh, and so on, you're going to end up with something that looks like a cubic function. Okay, and again, you could have some turns, so it could look like that, I guess. Okay, but that would be a cubic function, or any odd function. So all we're really going to talk about today is the end behavior of a polynomial. Okay? The end behavior, if I go back to the previous one, is what is happening on the two ends of the graph. We have the left end of the graph, what it's doing there, and we have the right end of the graph, what it's doing on that side. And if you understand what the end behavior looks like, you should have a pretty good start to an understanding of what the entire graph looks like. Okay? So the way we determine the end behavior is with this lead coefficient test, which is kind of wordy, but basically all we have to do is look at the coefficient of the highest term, that would be the lead coefficient, and that determines if the graph is going to rise or fall as you move towards infinity, both on the negative and positive side of the graph. So as you move as far as you can to the left on the graph, and as far as you can on the right on the graph, the lead coefficient, or the coefficient of the highest degree, tells us what's happening at those two ends. Okay? So we're going to look at some examples here. So first of all, if n is odd, so again that means if you have x cubed, x to the fifth, x to the seventh, okay, those are all like my highest degree, okay, and then the lead coefficient being something like 3x cubed might be what this graph looks like, okay, and then on this side the lead coefficient being negative, it might be negative 2x to the fifth, and so on for both of these. So there's going to be more stuff there, but it's an odd function because it's cubed. Don't confuse this even and odd with what we talked about last week or a couple weeks ago with even versus odd. This is strictly when we say when n is odd, that's the power, the highest power. Alright, so looking at those graphs, okay, what do we notice is happening on the left-hand side and the right-hand side of the graph as we move towards infinity? Okay, we see all the turns in here. We see all this weird movement in there. Okay, but we're not worried about that. We're worried about the end behavior. As our graph goes to infinity on the left-hand side, so over on the left-hand side, as we keep moving closer to infinity, going further left, what is our graph doing? Well, if we look at it, as x goes to negative infinity, okay, f of x, or the output of x, goes towards negative infinity as well. Okay, so that's the first thing that happens. So that means it's going down. Okay, if we look at the right side of the graph, so if we look over here at the right side, as the right side gets closer to the largest value we can possibly have, okay, so this time as x goes to positive infinity, okay, f of x goes to positive infinity as well. That's the second thing that happens. So anytime I have an odd power as for my lead coefficient, so x cubed, x to the fifth, x to the seventh, so on, and also that lead coefficient for the highest power is positive, okay, we're going to have this end behavior, where the end behavior says that if we're at negative infinity for x, f of x is at negative infinity. And if we're at positive infinity for x, f of x is at positive infinity. So what we can say, the final statement that we would say is that the graph rises to the right and falls to the left. Okay, and we can see that as our graph moves left, okay, so we're on the left-hand side of the graph over here, our graph is falling, and as we're on the right side of the graph over here, our graph is rising. Now, similar situation, but this time for negative lead coefficient, so that negative 2x to the fifth. Well, again, what happens on the left? This time, we see that on the left, our graph is increasing to infinity, okay? So this time, as x goes to negative infinity, because x is moving in the negative direction, f of x goes to positive infinity. And then we can see on the right side of the graph here, okay, as x goes to positive infinity, f of x goes to negative infinity. So those are the two things that happen, this time still with an odd power, but now a negative lead coefficient. Okay, so that final statement that we can write is that the graph rises to the left and falls to the right. And this would be the way on a test if you were asked to describe the end behavior, or on your homework if you're asked to describe the end behavior, these are the kinds of statements that you would want to write. Okay, the graph rises to the right, falls to the left. Graph rises to the left, falls to the right. Okay, so that's for an odd highest power and with a positive or negative lead coefficient. Now let's talk about what happens when that highest power is even. Okay, so we've got two even functions here, and again, not even functions, just an even highest power. So these would be something like This first one looks like it's maybe x squared. The second one looks like it's maybe x to the fourth. Okay. The lead coefficient on the left-hand side is positive, so that's going to be like a positive 2x squared. The one on the right is going to be negative lead coefficient, so that's maybe negative 3x to the fourth, and then you've got some other stuff going on in here too. Okay. But when we look at them again, what's happening on the left and what's happening on the right? Okay. So this time, we notice that as x goes to negative infinity, so that would be the left-hand side, f of x also, well, not also, f of x goes to positive infinity. It's going up. Okay? Our graph is going up as we move further left. So that's the first half of the statement. And in the second half, we look at the right-hand side. Okay? And on the right-hand side, as we move further, as we get to larger x values, our graph is still going up. Okay? So again, as x goes to positive infinity, f of x also goes to positive infinity. So with that even highest power, we're going in the same direction. The odd powers, we were going up and down on either end of the graph, and on the even powers, we're going in the same direction on either end of the graph. Okay. So this final statement here would be the graph rises to the left and right. Okay. And then we look at the negative lead coefficient. So this time it's a negative 3x to the fourth power. And we look at, again, the left side and the right side of the graph. So on the left side, again, we can see as x goes to negative infinity, okay, f of x goes to negative infinity because it's going down on the left-hand side. And then additionally, as x goes to positive infinity, f of x still goes to negative infinity. Because again, as we look at the graph, even left-hand side we're going down, right-hand side we're still going down. So we're going to negative infinity in the y direction. Okay? And so that final statement as well, the graph falls to the left and right. Okay. And that is it for today. That's all we're going to talk about. Your homework for this first part of the section is going to be on just describing in behavior and identifying the lead coefficient, the highest degree of the function. So that's it, and I'll see you guys in class tomorrow.